Good morning to everyone. I am Venu. I am present studying in BTech 4th year in Goodlevel Engineering College. My branch is Electronics and Communication Engineering. My project is washing machine simulator using PIC Microcontroller, which I was developed at Emertxe Technologies. The next slide is project objectives: simulating a smart washing experience. The primary goal of this project was to develop a comprehensive washing machine simulator that offers a realistic and interactive user experience. This involves several key objectives: user interactive interface, wash mode selection, water level control, CLCD display, safety and fuse feature. Next slide. Next slide is a condensed page. First one is introduction to embedded system. Second one is embedded C programming. Third one is PIC 16F877A microcontroller overview. And fourth one is peripheral used. And fifth one is software tools. And sixth one is functional requirements. And seventh one is implementation demo. And eighth one is conclusion. Introduction to embedded systems. Embedded systems are specialized computing systems designed to perform dedicated functions within a large mechanical or electrical system. Unlike general purpose computers, they are built in for specific tasks, often with real-time constraints, ensuring the operations are completed within defined time frames. Dedicated functionality means each embedded system is tailored to execute a particular set of tasks, optimizing performance and resource usage for the specific task purpose. The constraints with personal computers that handle a wide array of applications. Real-time operation means many embedded systems operated in real-time environments, meaning they must respond to inputs and produce outputs within strict time limits. This is critical in applications like automotive control systems or medical devices where delay can be having significant consequences. Ubiquitous presence. Embedded systems prevails in modern life, found in vast range of devices from household applications like washing machines, microwaves, to complex systems in vehicles, industrial machinery, and advanced medical equipment. Enhanced efficiency and reliability. That means by focusing on specific tasks, embedded systems can be highly optimized for power consumption, cost, and reliability. Their dedicated nature often leads to more robust and dependable performance compared to more flexible computing solutions. This is the introduction to embedded system. This slide. I will go to next slide. Programming, bridging software and hardware. Now let's look at how you are programmed the system. We use embedded C, a lightweight and low-level programming language designed for microcontrollers. Unlike standard C, directly access hardware registers is controlling the components like timers and LEDs and buzzers. Uses the fixed width data types like unit 8 underscore T and int 16 underscore T for memory efficiency. Has no standard I/O libraries like printf. All inputs and outputs are hardware driven. Mastering embedded C is essential for real-time embedded systems like this one. This one is a crucial for real-time operations. Next slide I will go to the explain. Next slide is PIC 16F77A microcontroller, the heart of the simulator. Our project revolves around the PIC 16F877A microcontroller, the brain of our washing machine. It is a 8-bit microcontroller with 14 pins, 40 pins, and widely used for educational and industrial purpose. It includes 14.3 kilobytes of flash memory for storing the program and 368 bytes of RAM. It can run at 5 MIPS, which is sufficient for handling multiple real-time operations. It has built-in timers and ADCs, that means analog to digital converters, EEPROMs, and UART UART from communication. UART means universal asynchronous receiver and transmitter. This MC is powerful, reliable, and perfect for simulation based on learning. It is PIC microcontroller. I will go to the next slide. PIC 16F877 architecture overview. You look at there. The first one is GPIO. GPIO means general purpose input and outputs. These pins are configurable as either inputs or outputs, allowing the microcontroller to interact with external devices like LEDs and keypads and switches. LEDs and buzzers. Buzzer. LEDs provide the visual indicator for the different modes or states, while the buzzer offers the audible alters from cycle completion or errors. CLCD, character liquid display, liquid crystal display, used for displaying the real-time information such as a current wash mode or remaining time and operational status to the user. Timers. The PIC microcontroller have 3 timers: TMR R0, TMR1, TMR2. The PIC microcontroller features multiple timers crucial for the generating the delays, the counting the events, and managing the time sensitive and operation within the washing machine cycle. ADC, analog to digital converter. This module converts the analog signals from the sensors, example from the water level detection, into digital values that microcontroller can be processed. UART, universal asynchronous receiver and transmitter, enable the serial communication with the other devices, usable for debugging or interfacing with more complex systems if needed. It is the matter of this slide. I will go to the next slide. You look at the peripherals. The peripheral components bringing the simulator to life. First one is CLCD or LCD. Next one is LED, light emitting diode. Next one is buzzer. And next one is fan. Is a tactile switch. The CLCD means the CLCD is essential for providing the real-time feedback to the user, displaying the current operational status, selecting the wash mode, and the remaining time for the wash cycle. LED, light emitting diode. It is a diode, one diode, light emitting diode. LEDs serves as a simple visual indicator, simplifying the power status and the active wash modes or the other important states of the washing machine simulator. Buzzer. The buzzer is used for it provides the audible alerts and notifications such as the completion of the wash cycle or an error condition or confirmation of user input. This is the fan. A fan is used to simulate the rotation of the washing machine's drum, visually representing the active washing or spinning process. When the washing machine on, the fan is rotating. When will be timer is off, it will be off. Fan is off. Next is tactile switches. These switches are crucial for the user input, enabling the selection of wash modes, pushing the operation, and simulating the lid open or close status for the safety features. Is a tactile switch. It is those peripherals. Those peripheral components are carefully integrated with PIC 16F877A microcontroller to create a comprehensive and interactive washing machine simulator, demonstrating practical applications of embedded system. It is only this slide. The first one is CLCD, LED and buzzer and fan, tactile switches. These peripherals are inbuilt in PICSIM lab. Are both timer modules, the heartbeat of control. Timer 0, 8-bit basic timer. The timer 0 serves as a fundamental 8-bit timer, primarily used for basic timing operations and generating the precise delays within the system. Its simplicity makes ideal for the start forwarding counting mechanics and event driving timing. Timer 2, it is timer 2, it is timer 1. 16-bit timer for duration. Timer 1 is a more robust and 16-bit timer specifically employed for managing the longer durations and critical timing sequences. This module is crucial for accurately controlling the various stages of the washing cycles, ensuring each phase runs for the correct period. Timer 2, 8-bit with pre-scaler or post-scaler. The timer 2 is an 8-bit timer enhanced with both pre-scaler or post-scaler capability. This configuration allows for the highly flexible timing, enabling precise control over the countdowns and the timing of different operational modes, adapting to various washing program requirements. These timer modules are integral to the washing machine's operation, providing the necessary temporal control for all functions, from duration washing machine cycles to the timing of specific actions like water filling or spinning. It is the timer modules. I will go to the next slide. Software tools. We are using the MP Lab XIDE and X8 compiler and PIC Lab. XCM compiler is a cross compiler. MP Lab XIDE I will once show again. I will show. Wait few more minutes, it will open. It is the MP Lab. The washing machine I created a project. This is the header files. It's not opening. It is loading. Okay. The header files you can see clcd.h, display keyboard.h, main.h and timers. I will show all these things. These are the header files. CLCD, character, liquid crystal display, those header files. It is digital keypad header files. Header file. These are defining things. It is the washing machine header.h file. I will show the source files also. This is a CLCD file. .c file. The digital keypad.c file is also peripheral on peripheral. ISR, interrupt service routine .c code. ISR means. Next I will show timers. It is a timers code. It is the washing machine function definition codes. This is the code. This is the total code of washing machine function definition.c code. I will show the main.c file. This is the main.c. And completed all the codes. We'll click on it. Okay, also you can show the build successful, no errors. The MP Lab XID will provide the hex file. Here the hex file is generated. This one. you can show the washing machine dot x dot production dot x5 hexadecimal code. That is hexadecimal file. Okay, I will close this one and continue the PPT. It is the MPLab XID. I will explain. This is XE8 compiler. The XE8 compiler is responsible for translating the C source code into machine executable hex files. This crucial step converts the human readable code into instructions that PIC microcontroller can be understand and execute, the forming the core logic of washing machine simulation. This is the use of XE8 compiler. Next, PIC Lab. PIC Lab provides a virtual simulation environment for the hardware components. This tool allows for through the testing and validation of embedded systems logic without need for physical hardware, significantly accelerating the development and debugging process. The combination of these software tools creates the robust development ecosystem, enabling the efficient and code development, compilation and realistic simulation of washing machines embedded system. This integrated approach ensures that the software logic functions as indeed before deployment on actual hardware. It is best for simulation, all these things. I will go to the next slide. It is the functional requirements and user interaction and display. This is a PIC Lab board. You can see that it is CLCD display. It is 7 segment displays. There are four displays are there. It is a tactical switches. It is a switches and RV register switches, direct access register. These are 6 1 2 3 4 5 6. These are the LEDs and is connected to port D. Is also LEDs is connected to the port B. It is the PIC microcontroller at EAP ROM. That is the relay switch 1 and relay switch 2. Relays are used for is working like the low power is used to controlling the high power circuits. These are some circuits, and it is buzzer. It is fan or motor. Switch 5 is used for the powering on or start. Switch 6 is used for the fuse and stop. Switch 4 is used for scroll and select. Switch 1 is lid open detection. CLCD is used for display mode and function and time, and buzzer gives the alters on event. I will go to the next slide. The washing modes and user flow, customizing the washing operations and water levels and user mechanism, timer activation. I will show the demo video next. The display screens, feedback and keeping the user informed. Initial prompt, and upon powering on CLCD displays the clear initial prompt is a press switch 5 to start. This guides user know how begin the interacting with the washing machine. Is the washing mode selection. Next one is water level selection, the timer and function display, completion message. I will show the demo video. Next, it is the fuse and safety feature, ensuring the control and security. Switch 6 is used for the fuse and functionality also. Switch 5 is also used to resume the operation. Switch 1 is used to the door open sensor simulation. I will show the demo video. Just wait, I will open to the PIC Lab. It is the PIC Lab. When the file is loaded here, it is the washing machine .h production.x file. Open it and select the clock frequency is 20 MHz and select the LCD is 16:4. Okay. Next, press the key 5 to powering on the washing machine. First switch on 5. It will show the powering on the washing machine. Next gives the washing machine washing program. You can scroll down, heavy, dedicates, strain, stain wash, eco cottons, woolens, bed sheets, rinse and dry. These are some slow this system. Bed sheets, click on rinse and dry, dry only, wash only. These are the washing programs. And select one thing, I will select the daily. In the long press the switch 4, it will go to the next message, next function will show the water level. These are the some things are here. Auto low, so when select the medium or high or max. These are things. I selecting the auto and long press again, switch 4, it will go to the next function. The press switch 5 in the start the mission, and switch 6 is the stop the and return back to the washing program. Understand? I click the switch 5, the program daily, and timer is activated, function is wash. When click on the 5 will start again. Resume, I click on the fuse and see switch 6, you can see the motor is stopped. I click on the switch 5, the motor is on. When switch 1 is clicked, the door is open, please close door. It will be generate that message. The timer is decreasing, show the function is changing. Wait some minutes. The timer is off when you get the display message. Buzzer is on. Program completed. Remove the cloths. It is the final message and return back to the wash program. This is a simulation of exam lab washing machine program. Conclusion and acknowledgements, key learning and future confidence. Realistic simulation achieved. The project successfully created a realistic simulation of a washing machine, accurately replacing its operational cycles and user interactions. This demonstrates the effectiveness of embedded system design in mimicking real-world applicants. Fully user control interface and real-time embedded logic is implemented. Simulation replaces the physical hardware. Utilizing the PIC lab, the project successfully demonstrated that complex embedded systems can be truly developed and tested through the simulation, significantly reducing the need for expensive physical hardware during the development phase. This project was successfully completed at Emertxe Technologies, where you gained practical knowledge of embedded systems and developed confidence in C programming and hardware logic. It is my complete project review. Thank you for your attention.